Let's look at what you will actually do in your quiz for this time. And you'll probably recognize these arrows. You remember that last time you stuck them together tip to tail in a CAD drawing. You used the graphical method to find the resultant of those two forces. Now let's find the resultant again, but this time we'll use X and Y components. And it's always interesting to try a problem two different methods and see if you come out with the same answer. And you should. So you can check your answer when you put these together in CAD and see, is it the same number you get when you put them together with X and Y components. All right. So what we're going to do is the classic method of making a table, and we'll find the X and Y component of each force, force A and B, and we'll add up all the X components, and we'll add up all the Y components. That's what we're going to do. And just a reminder about positive and negative. Those are really important when you're adding up X's and Y's. So remember this number line thing, that on the x-axis, positive is things going to the right, negative is things going to the left. On the y-axis, positive is things going up, negative is things coming down. Make sure you always look for that. So let's start by finding the components of that first force, force A. It's 100 pounds, and I've drawn a triangle to represent that force, 100 pounds at a 40-degree angle. And let's find its X component first. So that's what I'm showing in this table here. And that 100-pound force is the hypotenuse of the triangle. The X component, as you can see, is adjacent to the 40-degree angle, so it's the adjacent side of the triangle. When we think about the trig formulas, so ka toa, which one has hypotenuse and adjacent? It's ka. Its cosine is adjacent over hypotenuse. There it is. Cosine is adjacent over hypotenuse. Now we're looking for adjacent, so we can rearrange those terms. So it's hypotenuse times cosine. That'll give us adjacent. Our hypotenuse is 100. Our angle is 40, so we can say 100 times cosine 40. That will give us the X component, which is the adjacent side. And notice that X is negative this time. That force is pulling off to the left. So that's a negative X component. So make sure, if you were making one of these tables, make sure that you have a negative number in that table. Now we'll find the Y component. Here's our same triangle again. And the Y component is the side opposite the 40-degree angle. The 100 pounds is still the hypotenuse. So remembering SOHCAHTOA, which acronym has opposite and hypotenuse? It's sine. Sine, opposite, hypotenuse. Sine is opposite over hypotenuse. And again, we can rearrange the terms. We'll multiply both sides by h, so we have h sine equals opposite. H is 100 in this problem. The angle is 40 in this problem. So 100 sine 40 will give us the Y component. Now let's do the other force, force B. That's a 200-pound force, and I've drawn the triangle for it here. It's 200 pounds long on the hypotenuse, and it's a 20-degree angle. So 200 is the hypotenuse. The X component is adjacent to the 20-degree angle. SOHCAHTOA. Who has adjacent and hypotenuse? It's the cosine formula. Cosine equals adjacent over hypotenuse. Rearranging the terms, hypotenuse times cosine is, in this case, 200 cos 20. That will give us the x component, and we could fill that in on our chart. Now we'll do the y component of that force. 200 is the hypotenuse of our triangle. The y component is the side opposite the 20-degree angle, so we are looking for good old sine again. Sine is opposite over hypotenuse. Rearranging the terms, multiplying both sides by h, we get h times sine, or, in this case, 200 sine 20 will give us the opposite side, or the y component. And if we were writing this by hand, we could fill in the y component in our table. And now we have figured out all the x's and all the y's, and now we can add them all up. What do the x's all add up to? What do the y's all add up to? Whatever the x's all add up to, that is the x component of the resultant. Whatever the y's all add up to, that is the y component of the resultant. And here is our triangle for our resultant. And once we find these total numbers, you can see we have a big old triangle here. Great big x, great big y, and now we just need to find the magnitude of that thing and the angle that it's sitting at. So one option would be to draw the triangle in CAD, which would be interesting because you've already done some stuff in CAD with this one. And then you could measure the length of this hypotenuse, either dimension it or use the distance command. And then you could dimension that angle, and that would tell you what the resultant was. But what we're doing here is option 2. We're going to use the calculator to figure out the magnitude and the angle. So for the magnitude, we can go back to good old Pythagorean theorem again. And I have to say, you could use one of the trig formulas here. You already have the opposite and the adjacent, so you could use some other trig formula to find the hypotenuse. I'm just stuck on Pythagorean theorem, I guess. So, which is a squared plus b squared equals c squared. So a squared would be the x component squared. B squared would be the y component squared. And that equals c squared, which is, in other words, the magnitude squared. Whatever total you come up with is magnitude squared. And if you take the square root of that number, that tells you the magnitude. Let me just throw in something here. Forgive me if I'm being repetitive. This might be okay for you. On the other hand, you might think I'm going pretty fast. And I want to tell you that this is something I've struggled with all my life. I'm a smart person. I get good grades in school, but I have slow processing speed, and stuff like this, a math class or an engineering class, is very hard for me because of that processing speed. And so don't let that throw you if you have an issue like that too. And you will have your own strategies. My strategies are, 1, I will go through it repeated times. I seem to need repetition. 2, I will take notes. So if I'm watching a video like this, I'll have a notepad and I'll write down what they're saying. 3, I might get a a book that's not the book for the class, and I might try working practice problems. So anyway, I just want to say, if you feel overwhelmed by the speed, I hear you. Anyhow, where were we? We had just found the magnitude. Now we need to find the angle. So my favorite, as you can tell, opposite over adjacent. Who uses that? It's the tangent. Tangent of theta, I'm representing the angle with theta. Tangent of theta equals opposite over adjacent. So if we're looking for theta, we need the inverse of the tangent. Inverse tan, also known as arctan, inverse tan of whatever these two sides are, the opposite divided by adjacent, is going to give you angle theta. Last two slides. Here is the second problem, and you'll recognize these forces too. You assembled these two tip to tail using CAD last week. So now we're going to find the resultant of them again, this time using X and Y components. And again, the quiz in Moodle will step you through one step at a time. Which number is this? Which number is that? I do want to point out that again we have one force where its X component is pointing in the negative direction. And so I kind of did a shortcut here. You'll find all the X components of those two forces and add them up. You'll find the Y components of those two forces and add them up. The total X's are the X component of the resultant. The total Y's are the Y component of the resultant. And so here's a triangle showing the resultant, and there is where the hypotenuse will be the magnitude, and here's the angle of the resultant. You might be able to imagine how making a sketch of these things on scratch paper is a really good idea. And engineering students who don't have access to CAD, and maybe who don't visualize as well as you probably do have to do that on paper. I have to do that a lot because of my processing speed issue that I mentioned. So make sketches, make notes for yourself, do whatever you can, and please reach out if some of this is not making sense, and we'll try to hit it again.